Hello friends, let's learn about business layers, one of the important concepts in the universe design in the information design tool, that is IDT. So business layers is the third steps in our universe designs process, which will complete our universe design process. So what is business layer? A business layer is a collection of a metadata objects that map to SQL or MDX definitions in a database. So uh, first we will create a connection, then we will for design data foundation, which will have all the relational tables, and then based on the data foundation we will be creating a business layer, which will be a collection of a metadata objects. So these objects may be dimensions, measures, attributes. So that will be containing in folders, and this name of these folders and objects can be anything like means which can be understandable to the business users. Means they may not be technical names. So that is the main idea behind business layer, which will make our final universe more understandable to the users. So what are the components actually? Metadata objects. So under metadata objects, we will have dimensions, navigation paths, that means hierarchies, then measures, attributes, predefined conditions will again consider of filters. And when business layer is completed, it is published to CMS repository as .unix files. So earlier, when information design tool was not there, it was published as .unv, like .unv means universe file. But now it has been changed with the information design tool as .unix. So .unix file contains a business layer and its connection to OLAP or a data foundation. And the principal role of the business layer is to define and organize metadata before it is published. So this is a sample business layer, which how it looks. The first, if you see, this is the actual business layer, which when we develop the business layer, it will look like this. It will have folders. So on the right side, you will see what it is. So folders, dimensions, measures, attributes. So if you see, these are the folders. Dimensions will have this blue icon, means on the left side if you see. Then measures will have this yellow icon if you see. This is the measures. Then attributes will have this detailed information about any of the dimension. So maybe for client, it will have client ID, phone number, area code, client address, etc. So this is the structure. A folder can have subfolder. You see, this is client have subfolder as well as prices, and we can have many subfolders, means as we want in a universe design. So it all depends upon the business requirement, how we want it to be, how the structure of the folders and its objects. So coming to while designing the business layer, means this is the editor which will be there, means when we create a new business layer based on the relational data foundation or OLAP. So on the left side it will have the business layer for name, then there will be some properties. So one by one we will see these properties, what all these things properties. So these properties will have name, will be it's a business layer name, and that name will be appear when we will publish the universe to the repository. Description, we can give the description of the universe based on the business requirement, what it is all about. Query limits. So in this we have some restrictions which will allows like limit result set size to. We can specify some number of rows that are written in a query. Limit execution time. We can specify the number of minutes to limit the execution time. Warn if estimate exceeds, means whatever the time limit or number of rows we have specified, if that get exceeds, then it will be warned. The warning message will be displayed. Then coming to parameters, so whatever the business layer which are based on the data foundation, which will have the we can specify custom values for SQL generation parameters that override the default value or any customized value in the data foundation property. Then query properties will have again it is based on the data foundation, whatever the business layer. It can have allow use of subqueries. We can allow the subqueries in a query. We can have union, intersect, and minus operators, which will be useful for combining queries using dataset operators. Then allow complex operands in query panel. So this is all about and or operator, which is required while developing complex queries, and we can have the filters with the and or in query panel in the web intelligence. Summary will be displaying the number of each type of objects defined in the DL, means how many objects are there, what are the folders, and how many folders. So then what are the dimensions, what are the images, all will all come under the summary. Change data foundation, we can specify the data source for the business layer, either data foundation or OLAP connection. So these are the objects which are business layer objects. Dimensions, measures, navigation paths, and analysis dimension. This is when we have OLAP based business layer. So then attributes, filters will be for both. Named member sets and calculated members will be again OLAP only, and folders. So there may be subfolders as well, means as many as you want. So these are the main components of the business layer. Coming to the integrating the business layer components, how we can integrate. So within a universe, objects are grouped into a folder. So this grouping is for providing a structure for the universe and makes it easier for users to locate the project. And we can make subfolders in folders as well. So whatever the layout or whatever the structure it has been there in the business layer as a universe, it is all about folder and objects under it, or folder under it, subfolder, and in subfolder also we can have many objects as well there. So it is the structure. So coming to business layer dimension, means the first is as a component we will see one by one dimension, measure, and attribute, how we can have this means what are its properties. So for dimension objects, it is generally organized within the folder. So if you see, this is a country name, is when we can right click on this folder, that is business layer name, and we can say create new business layer dimension object. So once we click here, we can give the name as something, means if you want, means which is a business specific. Then the type will be dimension, then data type string, varchar, or number, whatever we want it to be there. Then select. So this is again table, so data foundation table, which is it is referring internally. Okay. And then SQL definition, means if you see, these are the different options. So and below that you will see these properties. So we will see one by one each properties for this. SQL definition will have this table and column name. So it will the business layer objects will refer internally to this tables column. Then key properties and advanced options. So in key properties, if that particular key which we are referring in the business layer from the database, if it is a primary key or a foreign key, then it will appear as whether it is a primary key or foreign key. So generally whatever the ID fields, it is either primary or foreign key, so it will appear here as a primary key or foreign key. In the advanced section, advanced properties, you will see access level. So it will be public, list of values. This access can be a different one, means whether it is public, private, controlled. So that we can change it from here, means based on the business requirement. List of values, we can associate a list of values. So a list of values, again it is a list of objects values can be which can be retrieved from the database table. So we can associate a list of values which is again required for the parameters if required. So we will be covering this list of values in another unit, a separate unit, primarily focus on that LOVs. Then objects can be used, results, conditions, sorts. This can we can select or unselect means based on the requirements. Display, we can create a display format means based on the requirement. Then the object will be displayed in the default or HTML or hyperlink. If you want to hyperlink display, then you can click on this option. Then the third properties which is there, source information. So it will have technical information, mapping, and lineage. So technical information will be having the information about the column name. So it is the original database column name. Then mapping will be having a displays initial formula information describe how a column has been specified. So revenue is the column. Then lineage will be having display source columns for the formula used to calculate columns in the database. Okay, lesson 3. Once we have created the objects in business layer, means we need to validate that object. So there are different ways to validate the objects. So the first one is business objects integrity check, which is the option available in the business intelligence tool, like information design tool, which will detect any errors in the SQL syntaxes used in the created objects, and what type of testing it does. Like, do the objects exist? Does that SQL appear correct? Means that query, whatever the syntax is syntactically correct or not? Are the results of the query correct? So this can be tested with the object testing. And in the query drawer, means if you want to test, means we can have this testing of the data means um, in the query drawer, that I will be showing you practically how we can test the objects. Now creating a measure object. So we covered about dimension objects. Now let's go to the measure objects, which is again an aggregate functions that map to a statistics in the database. So they represent the metrics for comparing dimensions. So basic aggregate functions have sum, count, average, maximum, and minimum functions. So when we create a measure objects, so the same way from here we can select a new, right click on this business layer name, click on new, then create a measure objects. So here you will see after measure name, this is a name, and then this type will be a measure, and then again we can view the function, whether it is sum, min, max, like this. So and then in the SQL definition we will have this uh, numeric values, whatever from the database it comes. So measure object inference, which is again one thing, means whenever we are using any aggregation function in the query. So it is a general rule in the SQL that if you are using any aggregation function, the whatever the co column names appear outside that aggregation function, it must come under group by function. So if you see, this is one query, select some of this, there is one formula from T1, that is table 1, and inner join T2 table 2. So this is one condition. So if you see, there is no group by, because we just have only aggregation function used in a select clause. Now, so if you see, if I add two fields like first name and last name here, so it must comes a group by there in this. So it must be grouped by a dot first name, a dot last name. So if this is the condition, I mean if you are adding, so internally whenever we are having an aggregate function, information design tool internally adds this group by functions to the SQL rule whenever we are creating any aggregated functions objects, that is measures. So that is the thing, but measure objects inference. So coming to measure object behavior, how it behaves means whenever it has been means what are the how it changes, how it change the data means when we are doing any measure object querying. So first is query process. At first it change its at query process, and there are two levels of query process: aggregation at select level and aggregation at project level. So select level is nothing but whenever user creates a query, Web Intelligence defines a SQL from the query and sends a select statement to the target database. So the data is returned to the microcube. The first level of aggregation now takes place in microcube. The results are projected into the report. So this is the first process, which is nothing but a simple, where whenever user creates a query, it fires to the database, and the database will return the data, and it is stored in the microcube, and then it is projected on the report. So this is the first step, which is nothing but select level aggregation. Now aggregation at projection level. So suppose you have the data, means whenever the query is created, the data is written in microcube, and then it is displayed on this report or a block like this: country, region, this sales revenue. So this is a projected data. So, and when projection happens, so now suppose in the report, if I remove this field region, if I remove this column region, then this projection change, whatever the total values is for UK, it is displaying here. For USA, it is displayed here. This is total across all these four rows. If you see, for all these four rows, and for UK this is the same, which will again display there. But if you are removing this, so this will again group by country only. For this is grouping by country and region, so that's why it is displaying the data separately for each region and each country. So now if I change this region from the report, now the grouping will change. It will just have the grouping on the country. That means for USA, whatever the total value is here, it will appear here. So that is nothing but aggregation at projection level. So whenever any block is edited, then the aggregation happens at projection level. So these are the two projection aggregation level. First is select level, and the second one is projection level. Coming to measure object testing, means how we can test the measure objects. So the first, there is a option like check integrity. So this will test its integrity based on the data and object's existence. If there is any conflict, or it will show up in the tool. Um, and we can also use query drawer to test the measure objects. Okay, coming to the one of the main, like this is again important concepts: delegated measure objects. So information design tool allows designers to create measures whose calculation is delegated to the database. So these are the delegated smart measures. A delegated measure is a measure that delegates its aggregation calculation to the database. Means it will ask the database to perform its aggregation. The tool will not, the information design tool will not perform its action. It will ask the database to perform whatever the aggregation. And sometimes, means this is needed. A universe design can create the delegated measures when conventional aggregation does not provide an accurate result for the measure. So there may be some situations where this will not allow, this conventional aggregation will not provide the inaccurate results for the measures. So for example, complex averages. So weighted averages, this is one more complex averages, which may not completed with the conventional aggregation, like it has been provided there in the tool. Then ratios, if you have found, if we want to find ratios. Then other measures that do not aggregate along all the dimensions in the report. OLAP sources where major aggregation are already available in the OLAP cube. So OLAP is again means where in OLAP cube the aggregation is already there, so it is not required at information design tool, so that can be delegated to the OLAP cubes. So how we can create, whenever we create a measure, so the step is same, means we need to create a measure, its type, And if you see this data type is numeric, and the projection function, if you see this is projection function, so we need to delegate it. So delegated, and we can say it's average of salary value or something, that we can use whatever function we want to here means here in this delegated measures. So this is the way means we can use delegated option in the information design tool. What are the benefits of delegated measures? It increases the query efficiency, makes non-additive measures available within the universe, use database-specific syntax to improve the performance, and provide optimization on the internal architecture of all vendors. As the calculation is delegated to the database, the processing of the data happens fastly or speed up. So that's why it improves the performance, and it will not um, slow down the performance of the reports, and extend the support of calculation for BI for reporting tools. So what are the best practices for delegated measures? So when report users manipulate the measures in the report, so this is the one major best practices we need to follow when suppose the report users occasionally changes the or manipulate the measures in the report. So in that way means it is better to delegate to the database the calculations to replace multiple query aggregates. So if there are multiple query aggregates, then we can use that delegated measures on calculations that could give inaccurate results when calculated in the report, and for measures requiring a division. So suppose there are some measures which requires division, that way we can use delegated measures. So coming to the so that's it. All for business layer. So uh, let's understand what we have covered. So what is business layer? How are the business layers published to the central management server? Why are the objects are grouped into folders in a universe? And what is the SQL rule for information of the group by clause? So business layer is a collection of metadata objects that map to SQL or MDX definition in the database, and how business layers publish to the central management server, that is as a .unix file, to provide structure of how the universe and makes it easier for users to locate particular objects. So this is required. So and what is a SQL rule for information? The when the select clause line contains an aggregate, everything outside of that aggregate in the clause must also appear in the group by clause. Okay. So this is all about a business layer. So I hope you have understood this concept. If you have any questions, then please put it in the comment section. If you like my video, then please like it and please subscribe to my channel as well. Thank you for watching.